With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is a block of mass 0.1 kg is attached to a cord passing through a hole in a horizontal frictionless surface as shown in the figure. Okay, the block is originally revolving at a distance of 0.4 meter from the hole with an angular velocity of 2 radian per second. Okay, so we are having a block here, okay, which is being revolved at a distance of 0.4 meter from the hole and with the angular velocity of 2 radian per second, and this surface is given to be frictionless surface. The cord is then pulled from below, shortening the radius of the circle in which the block was revolving to 0.2 meters. Considering the block to be a point mass, calculate the new angular velocity in radians per second. Okay, now see. Initially, this block was revolving at a omega of 2 radian per second, and we have to calculate the new angular velocity when the cord is pulled from below. Okay, there is a cord. This cord has been pulled from below, and the radius of the circle becomes 0.2 meter. At this point, we have to find the new angular velocity of this block. Now, if I draw this axis, okay, so this axis is passing through the center of this hole, okay, center of the disk, or we can say. Now we have, see, initially, let me write down the force first acting on this block. So there will be a normal force acting on the block due to this surface, and there will be a mg force acting in the downward direction due to the weight of the block, and there will be a tension force acting in the string. Okay, now it is given as frictionless surface, so friction force will not be acting on this block. Okay, now if I have to find the torque about this drawn axis about due to these three forces, then let's see, due to this normal force and the mg force, as they are the vertical forces and parallel to the axis, so torque due to vertical forces will become zero only, right? And now see, this tension force is passing through this axis. Okay, so again the torque due to this tension force will also become zero, okay, as it is passing through the axis. Hence we can say that the net external torque acting on the system is zero. Hence we can apply the law of conservation of angular momentum, right, which says that L1 will be equals to L2, okay, where L1 is the initial position where the block was revolving at a speed of 2 radians per second in a radius of 0.4 meters, and L2 is the angular momentum when the block will be moving in the radius of 0.2 meter with the new angular velocity. Okay, so L1 we can give as equals to I1 into omega 1 equals to I2 into omega 2. Now if I take the mass of this block to be m, which we have to consider as a point mass, so I can write the value of I1. The value of I1 will be equals to m into r1 square, okay, where r1 is the radius of the circle initially, into omega 1 will be equals to m into r2 square, okay, the new radius when this tension value was increased, multiply by omega 2. So now from here we can cancel out the value of mass, and the radius initially was given to be 0.4 meters, so that is 0.4 into 0.4 into the value of omega 1 is 2, and r2 is 0.2 meters, okay, 0.2 into 0.2 into omega 2. So from here we can cancel this out by 2, and also it is by 2. So omega 2 we can find out will be equals to 8 radians per second. So this is the new angular velocity of the block, and this is the required answer. Thank you.
For class 6 to 12, ITG and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.